Welcome dear students, we are on the CEC Gurukul lecture and we are in the series of electronic circuit. We are discussing the different component of the electronic circuit and today we are discussing the LED, that is a light emitting diode. In this lecture we discuss the what is the LED and how it works and how it is made. The previously we have defined the definition of an introduction of the LED. Now we define how we get the depletion layer and how it works, how we get the forwarding bias and how we can get the light as an output. So we require the semiconductor, and the semiconductor we use the PN diode, and PN junction diode we are using here. Diode, you see on the screen that here we are having the P type and N type material, and a depletion layer is created in between the P type and N type. At the junction, the free electrons from the N type material fill the holes and the P type from the P type materials. This creates the insulating layer in the middle of the diode. That layer is called the depletion layer. You see on the screen that P type on the left hand side and N type on the right hand side, both are arranged, the free electrons from the N side material and holes from at the P type material. So in between that we are having a depletion layer. A diode is simplest sort of the semiconductor devices. Broadly speaking, a semiconductor is a material that varying ability to conduct electrical current. So most semiconductor are made of a poor conductor that has had the impurities, atoms from the other materials are doped in it, and the process of that adding of the material is known as the doping. So doping is the adding of the different materials and we make it as a conductor. And in case of the LED, the conductor material is typically we use the aluminum gallium arsenide, and in the pure aluminum gallium arsenide, all of the atoms bond perfectly with their neighbors that have the no free electrons, leaving no free electrons, that is the negative charge particles to conduct the electric current. In the doped material, additional atom change the balance, either adding the free electrons or creating the holes, where the electrons can go. Either of these alterations make the materials more conductive. So semiconductors with extra electrons is called the N type materials, and since it has extra negative charges, charge particle, so in N type material the free electrons move from negative charge area to the positive charge area. Similarly, a semiconductor with the extra holes is called the P type material, since it effectively has the extra positively charged particles. So electrons can jump from hole to hole, moving from a negative charge area to a positive charge area. As a result, the holes themselves appears to move from a positive charge area to the negative charge area. So a diode consists of the section of N type material bonded to the section of the P type material with the electrodes on each end. So that is by cathode and anode, and this arrangement conducts the electricity in only in the one direction. When no voltage is applied in the diode, then electrons from the N type materials fill the holes from the P type material. Means N type material, the holes will be in the N type, the electrons will be in the N type and the holes in the P type, along with a junction between these layer. That layer is the depletion layer. That is also called a depletion zone. In this depletion zone, the semiconductor materials return to the original insulating state. All of the holes are filled, so there is no free electrons or empty spaces for electrons, and electricity can flow in it. To get into the depletion layer, we have to get the electrons moving from N type area to the P type area and holes moving in the reverse direction. So we can remove the depletion layer if directly the N type materials moves to the P type materials and P type material moves to the N type material. You can see when the negative end of the circuit is hooked up to the n-type layer and the positive end is hooked up to the p-type layer. The electrons and holes starts moving and the depletion zones disappear. Means easily the freely electrons can move in the holes. If it is a forward bias, then the from electrons will go into the p type and p go to the n type. So to do this, we connect the n type side of the diode to the negative end of the circuit and p type of the and the p type of the diode connect with the positive end of the circuit. So electrons flow in the n type materials are repelled by the negative electrons and drawn to the positive electron. That's why we move from the n type to p type. The holes from the n type materials move the other way. When the voltage difference between the electrodes is high enough, the electrons in the depletion layer are boosted out of their holes and begins moving freely again, and the depletion zone disappears and the charge moves across the diode. And we try to run the current on the other way. The p type connected to the negative end of the circuit and n side connected to the positive end of the current will not flow in it. So negative electrons in the n type materials are attracted to the positive electrode. So the positive holes in the p type material are attracted to the negative electrodes. So no current flows across the junction because the holes and the electrons are each moving in the wrong direction. That's why it is moving in the reverse direction, so it is not possible to get the output. So depletion zone increases. So the main purpose is to remove the depletion layer. We can see on the screen then the positive end of the circuit is hooked up to the n type layer and the negative end is hooked up to the p type layer. The free electrons collect on one end of the diode and holes connect on the other end. The depletion layer gets bigger and bigger. So it is not possible to get the output in this case. The interaction between the electrons and holes in this setup has an interesting side effects. It generates the light. When there is an interaction between the electron and holes in this setup, then it has the interesting effect. That effect is generation of the light, and that's why it becomes a light emitting diode. So how we can produce the light by using this system? The light is a form of the energy that can be released by an atom. So it made up of the many small particles like packets and have energy and momentum but no mass. So these particles are called the photons, and that photons generates the light, and the most basic unit of the light is the photon. So photons are released as a result of moving of the electrons. As the electrons move in the forward direction freely, then photons will produce. In an atom, electrons move in the orbital around the nucleus. Electrons in the different orbits have the different amount of energy. Generally speaking, we can say that electrons with greater energy move in the orbit further away from the nucleus. For the electron to jump from a lower orbital to the higher orbital, means is going from the lower level to the higher level, something has to boost its energy level. And conversely, we can say that an electron releases energy when it drops from the higher orbit to the lower orbit. So this energy is released in the form of the photon, and that photon generates the light. If a greater energy drop releases a higher energy photon. so which characterized as a higher frequency. So we require the more free electrons moving across a diode that can fall into the energy holes from the p-type layer. So more and more electrons will move in a diode from n-type to the p-type. So this involves a drop from the conduction band to a lower orbit. So the electron releases energy in the form of the photon. This happens in the diode, but we can see only the photons when the diode is composed of the certain materials. Then we can get the different colored light. The atoms in the standard silicon diode, the example arrange where the electron drops a relatively shorter distance. So as a result, the photon frequency is so low that it is invisible to the human eye. So it is in the infrared portion of the light spectrum. This isn't necessarily a bad thing for the course. Of course, infrared LED are ideal for the remote controls and among the other things. So that light is also used. But what about the visible light emitting diode? That light up the number of diodes clock and are made of the material characterized by a wider gap between the conduction band and the lower orbit. So the size of the gap determines the frequency of the photon. In other words, if we determine the color of the light, while LED are used in everything from the remote control to the digital displays of the electronics, visible lights are popular thanks to their long lifetime and miniature size. The size are getting small. Depending on the material used in the LED, they can build the shine in the infrared, ultraviolet and all colors of the visible spectrum in between that. While all the diode release light, so most don't release the light, and still it is very effective. In the ordinary diode, the semiconductor material itself end up absorbing a lot of light of energy. We can see on the screen that there is a absorption of the light of the different energy. You see that the positive terminals move towards the negative and negative holes move towards the positive, and there is a recombination that we can understand by seeing this video. We can see there is a one type of semiconductor, this is another type of, that is P and N junctions are put together. Now this will form the depletion layer that is connected with the battery. Now how it works, you see the positive and negative, the electrons move from the right hand side and it recombines and it releases the energy. Now how the positive charge carrier and the negative charge carrier combines and it will release the energy. You see there is not a requirement of the depletion layer, but as a number of electrons are more, it will release the energy. So whenever there is a combination of the positive and negative charges, then it will release energy. You see that arrow represent the release of the energy by using the different semiconductors, and that is the LED. So it blinks when large number of the electrons and holes are moving. So LED are specially constructed to release a large number of the photons outwards. Additionally, they are housed into a plastic bulb that concentrates the light in a particular direction. So most of the light from the diode bounces off the side of the bulb, traveling on through the round end. So lighting, how the color we can get. So the light emitting diodes gets its color, unlike the normal signal diodes, which are made of the detection of the power rectification, and which are made from the either the gallium or which is made of the germanium or the silicon semiconductor. Light emitting diode are made of the then semiconductor compounds such as gallium arsenide, GaAs, gallium phosphide, GaP, GaAsP, sometimes we use the 3 combination, silicon carbide, gallium indium nitride, we use all mixed together at a different ratio to produce a different distinct wavelength of the colored, and that is used to get the colored light. And different LED compound emit the light in specific region of the visible light spectrum. So the exact choice of the semiconductor material depend upon the requirement, which wavelength we require and which output we require with the light that will give the particular color. So you see on the screen we are having a different materials which will produce a different color output. These are the some of the materials, semiconductors which produce the light in a particular wavelength, and this is the material. Second is the wavelength, which is at which the color which it is producing, then it is the zone in which it is working. So this is the table. Now the actual color of the light emitting diode is determined by the wavelength of light emitted. It may be blue, it may be red, that will define by the output, and which in turn determined by the actual semiconductor compound used in forming the PN junction during the recombination. So therefore the color of the light emitted by the LED is not determined by the coloring of the LED plastic body, although it is slightly colored to both enhance the light output and to indicate the color when it is not being illuminated by the electrical supply. The purpose of the colored epoxy is that so that we can get the indication of the color, that which color of this LED is. So the color is decided by the semiconductor material doped which we are using. So in the light emitting diode are available in the wide range of the color, with the most common being the LED, amber, yellow and the green, and thus widely used as a visible indicator and moving with the displays. So recently we use the blue color, and from the table we have seen that the main p-type dopant used in the manufacturing of the light emitting diode, like gallium, and that is atomic number is 31, and the n-type dopant, that is arsenic, that atomic number is 33, giving the resulting compound of the gallium arsenide GAS crystalline structure. So problem with using the gallium arsenide on its own as the semiconductor compound is that it radiates large amount of low brightness infrared radiation, that will be in the range of the 850 nanometer to 940 nanometer approximately from its junction when forward current is flowing through it. So the amount of infrared light is produced is okay for the remote control, but it is not useful for preparing the LED for indicating the light. But if we add the phosphorus, that is a P, with the atomic number 15 as a third dopant, the overall wavelength of the emitted radiation is reduced to below the 680 nanometer, that will come under the visible region. So visible red light of the human eye can be seen by it. So by using the phosphorus doping, we can make it as a visible LED. Further refinement in the doping process of the PN junction have resulting in range of the color spanning the spectrum of the visible light, as we have seen about the infrared, ultraviolet region. So how we can define the color? By mixing together a variety of the semiconductor metals, and we can get the different colored LEDs. So type of light emitting diodes are gallium arsenide, and second is the gallium arsenide phosphide. So GAAS and GASP, that is the gallium arsenide is the infrared, and the gallium arsenide phosphide is the red to the infrared and orange. And other type is aluminum gallium arsenide, that is high brightness red orange and the yellow color. and only the gallium phosphide present the red, yellow and green color. Aluminium gallium phosphide also produce the green color. So gallium nitride produce a green and emerald color, and here is a near ultraviolet, bluish, green, blue, and these are the different type of the colors we can get by using the different semiconductor materials. Like zinc selenide produce the blue color. So when we require the blue LOD, then we dope the selenide in the zinc ZnSc. Aluminum gallium nitride is also used in the ultraviolet region. So here different type of the colors, we by using the different type of semiconductor we can get the different colored light. And you all know the application of this LED, that this LED are used nowadays in the different appliances, from the small to the large, in the remote to the mobile to the electronic gadgets and many more. So the LED being a smaller in size, they can be stacked together to form a numeric and alphabetic display, the high density display, and sometimes it used in the smooth control of the remote, and there are the many more application of the LED. So we will further discuss about the LED in the next lecture. Thank you very much.